Alright, welcome to my channel Mathematics Clinic by Tutor Chris. So in today's video, I'll be solving this problem concerning differentiation, and I'll be making use of two different methods. The first one will be first principle, and the second one will be the chain rule, which is also known as the composite function. Alright, so if you haven't subscribed to my channel, make sure you quickly do that now. Invite your friends to my channel, turn on your notification, and if you find my videos interesting, share it with your friends. Okay, now let's move on together. So I'll be making use of the first principle. Okay, don't forget that the function is we want to find the s dt and the s dt when our t, sorry for that, when our t, sorry, when our s, sorry, let me clear that. When our s is equals to the root of t, okay, so don't forget that the first principle says that you have the y dx to be equals to bracket of x plus h, where h is a change in x, okay, z of x h. That is, we take the limit of this as x approaches 0. Okay, but don't forget in this instance, instead of our y now, we are having x, which is a function equals to root of t instead of x. So we'll be taking finding the s dt, and the formula now will be instead of x, we are going to have t plus h, which is now changing t, and instead of f of x, we are going to have our s. We're going to have s all divided by h. We're going to take the limit of h as it approaches 0. Right, that's good. Don't forget this. So now let's move to the next page. Alright, so we said we're having the s over the t equals to the limit as h approaches 0 over s sorry, t plus h s all divided by h. So we take the limit of this. Okay. So now don't forget that the problem given to us is that s equals to the root of t. So instead of writing this, we are going to have root of everything here. So this implies that we're having the s dt equals to limit as h approaches 0, the root of t plus h minus s, all divided again by h, all divided by h. Alright, so now we're having the s dt to be equals to limit as h approaches 0. Okay, this will now be root of t plus h. Instead of negative s now, I'll be having minus, because our s, don't forget our s is equals to the root of t. So I'm having minus root of t all divided by h again. Alright, this is cool. So now what I want to do is that I'm going to rationalize the numerator. So if I do that, I'll be having root of, okay, I'll be having root of t plus h minus root of t all divided by h, and then multiplied by root of t plus h plus root of t, that's what we call rationalization, over root of t plus h plus root of t. Alright, so now we're multiplying this with this. Also this, the root of t plus h here, we multiply the root of t plus h here, the root of t plus h also still multiply the root of t, and the negative root of t we multiply the root of t plus h, negative root of t also will multiply root of t here. So I will apply the same thing to this, that is h will multiply the root of t plus h, and h will also multiply the root of t. Okay, so let's dive in together. So we're having the s dt to be equals to, that is root of t plus h multiplied by root of t plus h. We are going to have a square root of t plus h squared. Square root of t plus h all squared. Okay, and this root of t plus h multiplied by root of t. So I'm going to have plus root of t into root of t plus h. Root of t plus h. Root of t plus h. Alright, and this will now be negative root of t plus h. So instead of writing this, I can clean this up so that this place will be okay for me. So look at what I want to do now. Alright, now we say that root of t plus h multiplied by root of t plus h, we're having root of t plus h all squared. Okay, root of t plus h multiplied by root of t, we are going to have t into bracket of root of t plus h, and then negative root of t multiplied by root of t plus h. So this will cancel the positive root of t plus h we are having, so that is 0. So now I'm going to multiply this together, that is, this will now be negative sign instead of positive. I'm going to have negative. Okay, root of t multiplied by negative root of t multiplied by positive root of t, we are going to have negative root of t all squared. Alright, all over h into, that is h multiplied by root of t plus h. I'm going to have h into bracket root of t plus h plus, if you close the bracket, h multiplied by root of t again, we are going to have h root over t. That is fine. Alright, so if you have any problem with this, you can just pen it down in the comment section. I'll make sure I attend to it. And if at all you have anything in mind you want to say, you can also get across to me to the comment section. Alright, so we are going to continue from here now. So don't forget we're having the root of t plus h all squared. You can put that down, minus root of t squared all divided by root of h into root of t plus h, okay, plus h into root of t. So you can pen that down because I'm going to the next page so that you understand where we stop. Okay, now let's move to the next page. Alright, so this is what we are having now, that is we're having root of t plus h all squared, root of t plus h all squared, sorry for that, all squared. Then we're having this minus root over t squared, then all divided by h into root over t plus h, root of t plus h, okay, plus h into root over t. Okay, now you can see that in this the numerator here, don't forget is our ds dt that we are looking for, which will now be equals to this square root can cancel the square. So I'm going to have t plus h. Okay, square root will also cancel the square. I'm having negative t over. Now I can factor out h here. If I factor out h, I'm going to have h into root of t plus h. Okay, close the bracket plus. Now if I factor a out h, so I'm having h, you divide this by h, we are going to have a root of t plus h. And now if I factor out h here, I'm going to have a root of t left. Okay, in bracket now. So I factor the h. So now the s, the t, don't forget that our ds, the t is the limit, or we take the limit of this as h approaches 0. So I'm having the limit of this as h approaches 0. Now if we look at this, positive t we cancel negative t. So I'm having this to be equals to h all over h into square root of t plus h plus root of t. Okay. Now our ds dt will be equals to limit as h approaches 0. Now here h we cancel h, so we are going to have 1 over root of t plus h plus root over t. All right. So now we take the limit as h approaches 0 for the for this first one, which is root of t plus h. That is, as the limit approaches 0, we are going to have root of t plus h. As h approaches 0 will be equals to root of t plus 0, root of t plus 0, which is same thing as root of t. All right. So if you are new to this channel, don't forget to subscribe to my channel. So when next I upload a video, you'll be the first to watch. And don't also forget to invite your friends to my channel so that they can also enjoy what you are enjoying. And in fact, if you find my videos interesting, you can share it with your friends and your colleagues in school so that they will also have chance to watch my videos. Okay, so now let's move to the next page. You can also jot this down. So because we are moving to the next page now, let's go to the next page. All right, so this is what you're having next page. Our ds dt equals to limit of as h approaches 0, we're having 1 all divided by that's root of t plus h, okay, plus root of t. We are still making use of the first principle, so don't forget that. So if you take the limit as h approaches 0 for the root of t plus h, if we take the limit as h approaches 0 for this root of t plus h, we are going to have root of t plus 0, and this is equals to root of t. So now that means that if we take the limit, we are going to have ds dt to be equals to 1 all over root of sorry, let me clean this. Okay, so we are going to have 1 all over and divided by don't forget that if you take the limit of this, now we are going to have the root of t. So I'm having root of t plus this root of t. So ds dt will now be equals to 1 over root of t plus root of t, that's 2 root of t. So I can say my ds dt is equals to 1 over 2 root of t. Alright, this is cool. So this is first principle. Now I'm going to make use of the second method, which I call the chain rule or the composite function. So let's dive into that. Alright. Okay guys, so don't forget to having to find our ds dt, if s equals to root of t. So I've been making use of the chain rule now, or composite function chain rule. And this chain rule says that if you're having the x, the y, to find the x, the y, we say the x, the y equals to the y, the u, multiplied by the u, the x, where we cannot cancel out this, the u. Okay, So now instead of having the x to y, this will change to the s the t. That is, we are differentiating oh sorry, I mean the y dx. That's a mistake, sorry for that. I mean the y dx. So now instead of that, our y now is s because this is the function, so we are having the s and we are differentiating with respect to t, so the s dt will be equals to, instead of y again, we are going to put s, so we are going to have the s. Now I can make use of the u, that's just substitution, multiplied by the u over the t. Okay, I hope you understand what I just did here. Alright, now I will now let u, so that I can substitute the value of u into something. Let u equals to my u will be, don't forget that before moving on, instead of having s equals to root of t, don't forget that this is same thing as s equals to t to the power of 1 over 2. Square root means to the power of 1 over 2. So I can let my u to be t. Okay, and if I differentiate u with respect to t, differentiating u with respect to t, I'm going to have 1. And then now my y will be equals to u to the power of 1 over 2. And if we differentiate this, that is, we differentiate, this is my x. If we differentiate this s with respect to u, now we are going to have, or let me say y. I can make use of y too, because I've already written y here, or y, let me say y. Let me make use of y, sorry. So now I'm having my y to be u to the power of 1 over 2. So my dy du, that is differentiating y with respect to u, will be equals to 1 over 2 u. Now 1 over 2 minus 1, that will be negative 1 over 2 to the power of negative 1 over 2. Alright, don't forget to pen this down. Maybe as we are diving into this problem, maybe you find some concept difficult, you can quickly put them down in the comment section, or ask any kind of question you wish to ask, so I'll make sure I attend to them. Okay, so now write this down so that we will understand what we are doing and where we stop. So we have the y, the u equals to 1 over 2 u to the power of negative 1 over u. So I will continue from there in the next page now. So now let's move to the next page. Alright guys, don't forget that we stop here. That is, our u equals to t, and our du dt equals to 1. Our y, or let's say y, equals to u to the power of half, and our dy du, that is differentiating y with respect to u, the y du equals to 1 over 2 u to the power of negative half. Alright, and don't forget that the formula for the chain rule, and which is also known as the composite function, says that if you differentiate dx with respect to dx dt equals to dy, or you can also make use of x, it doesn't matter, dy du, okay, multiplied by du dt. So this y, you can also write s, don't forget. So now I will substitute the value I'm having here now into that. That now implies that we are going to have our dy du is 1 over 2, that's 1 over 2 u to the power of negative 1 over 2, multiplied by du dt. What's our du dt, which is 1. Alright, so I will make use of our substitution now. That is 1 over 2. What is our u? Our u is t. So if our u is t, okay, to the power of negative half, multiplied by 1, so it doesn't matter. So our ds dt will now be equals to 1 over 2. Don't forget I said that square root of t is same thing as t to the power of half. So I will apply that now. Don't forget we are having negative here, so that means I'm having this multiplied by 1 over what's that, 1 over root of t now, because this is same thing as 1 over t to the power of half, so I'm having 1 over root of t. So our ds dt is now equals to 1 over 2 root of t. which is same thing as what we got when we are making use of the first principle. So if you like this kind of video, don't forget to subscribe to my channel, invite your friends, so when I upload the video, you'll be the first to watch. All right, thank you, see you next time.